Greetings, welcome to this new video about superposition theorem. Solve the problem number 8. In this video, I will demonstrate the application of the superposition method to solve a problem, and I will guide you through the step-by-step process of using superposition to solve the problem at hand. Let's consider this network consisting of 4 resistors labeled R1 through R4, as well as 3 independent sources. The question now is to use the superposition method to find the current I through the resistor R2 and to calculate the power delivered to the 3 ohm resistor. Let's move on to the solution. First, we begin by identifying each independent source in this circuit. This step involves a clear understanding of the source that will be analyzed separately. In this circuit, we can observe 3 independent sources, 2 independent voltage sources, and 1 independent current source. Next, we proceed to deactivate all but 1 independent source in the circuits. This involves replacing the inactive voltage sources with short circuits, which means 0 voltage, and the current sources with an open circuits, which means 0 current. Let's begin first by activating the independent voltage source VA and deactivating the independent current source IS and the independent voltage source VB, which will be replaced respectively by an open circuit and a short circuit. The next step is to solve the circuits using conventional techniques. Let's start first by calculating the equivalent resistor of this circuits, which given by R1 plus R2 plus R3 parallel to R4. That means R equivalent is equal to R1 plus R2 plus R3 times R4 over R2 plus R3 plus R4. If we replace the resistors with their numerical values, we obtain R equivalent is equal to 4 ohms. Let's move on now to calculate the total current here in this branch is equal to VA over R equivalent. If we replace VA and R equivalent with their numerical values, we obtain IT is equal to 5 amps. Now, in order to calculate the current I1 through the resistor R2, we are going to apply the current division rule. That means I1 is equal to R4 over R4 plus R2 plus R3 times IT. And if we replace the resistors and the current with their numerical values, we obtain I1 is equal to 2.5 amps. Now let's consider the independent current source IS active and the independent voltage sources VA and VB inactive, which will be replaced by a short circuit. In order to calculate the current I2 through the resistor R2, we are going to apply the nodal analysis method. At node 1, we can write negative V1 over R1 plus V2 minus V1 over R3 is equal to IS plus V1 over R4. And if we replace the resistors and the current with their numerical values and we continue simplifying this equation, we obtain negative 7 V1 plus 4 V2 minus 8 is equal to 0. Let's move on now to node 2. At node 2, we can write IS is equal to V2 over R2 plus V2 minus V1 over R3. If we replace the current and the resistors with their numerical values and we continue simplifying this equation, we obtain negative 3V1 plus 4v2 minus 6 is equal to 0. Now, by performing 1 minus 2, we obtain negative 4 v1 minus 2 is equal to 0. That means v1 is equal to negative 2 over 4 is equal to negative 0.5 volt. And from equation 2, we can write v2 is equal to 3v1 plus 6 over 4. And if we replace v1 with its numerical value, we obtain v2 is equal to 1.125 volt. Now, according to Ohm's law, the current I2 is equal to v2 over R2. And if we replace v2 and R2 with their numerical values, we obtain I2 is equal to 0.375 amps. Now we are going to consider the independent voltage source VB active and the independent current source IS and the independent voltage source VA inactive, which will be replaced respectively by an open circuit and short circuit. Let's start first by calculating the equivalent circuit resistor of this circuit, which we given by R4 plus R2 plus R3 parallel to R1. That means R equivalent is equal to R4 plus R2 plus R3 times R1 over R2 plus R3 plus R1. If we replace the resistors with their numerical values, we obtain R equivalent is equal to 5.33 ohms. Let's move on now to calculate the total current. Is this current in here in this branch is equal to negative VB over R equivalent. If we replace VB and R equivalent with their numerical values, we obtain IT is equal to negative 3 amps. In order to calculate the current I3 through the resistor R2, we are going to apply the current division rule. I3 is given by R1 over R1 plus R2 plus R3 times IT. And if we replace the resistors and the current with their numerical values, we obtain I3 is equal to negative 1 amps. After completing the analysis for each independent source while treating the others as turned off, the subsequent step is to combine the results algebraically. This process enables us to determine the overall circuit response. That means the current I is equal to I1 plus I2 plus I3. And if we replace I1, I2 and I3 with their numerical values, we obtain I is equal to 1.875 amps. Let's move on now to calculate the power delivered to the 3 ohm resistor, which is given by 3 times I squared. And if we replace I with its numerical value, we obtain P is equal to 10.547 watt. After we finish the calculation, we conduct a simulation using SPICE in order to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. This is the independent source VA, the independent source VB, and the independent current source IA, resistor R1, R2, R3, and R4. Let's move on to analysis. DC analysis, calculate nodal voltage. We can see here that the current I is equal to 1.88 amps. And the power delivered to the 3 ohm resistor is equal to 10.55 watt. After completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves a validation of our work. Alright, Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another problem about superposition method. Take care and bye bye.